leaps further into space with the launch of a solar observatory. Astrolab's Flex rover is now the official rover of the SpaceX lunar missions, and the Deep Space Network is in desperate need of some upgrades. Barely a week after India's ISRO landed their Chandrayaan-3 vehicle on the lunar South Pole, the space agency launched another tricky mission, this time to the Sun. The Aditya L1 is a solar observatory launched on September 1st on board a polar satellite launch vehicle, and like other solar observatories, Aditya's whole purpose is to take measurements of the Sun, specifically how the Sun's corona behaves. Its destination is the L1 Lagrange point, more than 1.5 million kilometers from the Earth, a journey that will take about 4 months and several progressive burns in low Earth orbit to reach. Lagrange points are little pockets of stable gravity in shifting orbits of a planetary system, normally between two specific bodies, as it makes the maths easier to work out. In order for Aditya to have the best viewing angle, it needs to be sitting at L1, the point of equilibrium between the Earth and the Sun. In this orbit, the observatory won't ever be blocked by an eclipse. NASA's James Webb Space Telescope sits at the L2 Lagrange point for the same reason, and the L1 point is already home to the Solar Heliospheric Observatory, which was launched in 1995. But India didn't send Aditya into space just for bragging rights. The ISRO is trying to solve one of the biggest remaining mysteries about our Sun, the coronal heating mystery. The gist of this problem is that the surface of the Sun, called the photosphere, is only about 6,000 degrees Kelvin, or about 5,730 degrees Celsius, but the corona, the outermost layer of the Sun's atmosphere, gets to about 2 million degrees Kelvin, which is such a large number in Celsius that our calculator exploded. Understandably, astronomers are wondering why the surface of the Sun is colder than the furthest layer of its plasma, and so the ISRO thought it would be a good use of their resources to help figure the physics mystery out. And honestly, it is. Heliophysics is a growing field of study, and understanding how the Sun's corona works could be pivotal to working out some sort of warning system for when that big nuclear ball in the sky decides to send a planet-sized arc of plasma our way. But that's just the easiest reason for this being a smart move. The more important reason, to India anyway, is that they can do this. And we don't mean that they should do this just to flex. Things don't tend to work out well for agencies that try to do things just to prove a point, as the Roscosmos folks recently found out with Luna 25. What we mean is that the ISRO is a smaller agency with a tighter budget than, say, NASA or the ESA. Like China, they have plans for their own space station and probably want to send a crew to the moon, but without support they would have a hard time achieving those goals, and it's definitely unsafe to make the attempt too soon. So the ISRO is thinking like the bigger agencies. They are planning for missions they can achieve. Look at the Chandrayaan missions. Landing on the moon is difficult and costly, and it took the ISRO 3 missions to do it, but there was a need for someone to land on the south pole of the moon and start taking measurements, because the US-led Artemis missions and the Chinese lunar missions both require that sort of data. India could help both while staying within their capabilities and means. Jump forwards to Aditya L1 and we see a bunch of aging solar observatories and a question that could be answered, or at least helped towards an answer, with a 100-kilogram coronagraph-equipped satellite. That's something India can do. And in the meantime, they are forging ahead with design and testing for their Gaganyaan crewed spaceflight project. At the beginning of August, the ISRO were busy testing drogue parachutes at their facility in Chandigarh, and it's looking pretty good. The plan is for the first crewed flight to take place in 2024, which seems very doable provided their flight tests at the end of 2023 work out. This has been a pretty spectacular couple of months for the Indian space program. They've gone from obscurity to confidently standing shoulder to shoulder with NASA, the ESA, and the Chinese National Space Administration, and they've achieved that by being careful and measured in their goals and approach. SpaceX might still be in the design phase for their human landing system, but word from Venturi Astrolab reveals that they now have a rover to plan for. On September 1st, the small aerospace company announced that they had signed a deal with SpaceX to make their Flex rover available to the large launch provider's private missions using their prototype Starship vehicle. The Flexible Logistics and Exploration rover is a unique planetary mobility vehicle able to expand and contract in order to accommodate different-sized cargo loads with its underslung bay. The rover is equipped with a flexible arm that can have a variety of tools, but it's also designed to have a modular loadout of equipment in general, so operators can switch out the functions of the Flex as the mission requires. It is powered by lithium-ion batteries, which are in turn fed by a pair of side-mounted and extendable solar panels and can even be remotely operated, removing the standing control area if need be. It's even got enough insulation to keep it running during lunar nightfall when temperatures can get as low as -130 degrees Celsius. Almost everything about the Flex rover looks like an improvement over any other rover design currently being showcased, which is likely why SpaceX decided to go with Astrolab's Slick Explorer instead of designing their own. The other reason for their choice is that the Flex isn't just a design, it's been built and tested. In 2022, Astrolab took a rough prototype out into the California desert and let Commander Chris Hadfield drive it around the dunes for a bit. Even back then, the company was hoping to catch the eye of SpaceX, making their vehicle to such robust standards that it could survive anything the moon or Mars could throw at it. Quote, "We want the hardware to be super robust so that they can essentially drive it like they stole it and not have to worry about it," said CEO Jared Matthews, who is a veteran of both the Jet Propulsion Laboratory and SpaceX. Matthews worked on the Spirit and Opportunity Mars rovers and then went on to have a hand in the Crew Dragon capsule, so he knows what he's doing. The plan is for the Flex to fold up into its stowed configuration and get packed into the cargo area of the Starship HLS. Once on the moon or Mars, or whatever the Starship lands on, the Flex can be deployed with the onboard elevator and can be used by the crew either manually or remotely. But the private SpaceX mission to the moon won't be until after Artemis 3, 2026 at the earliest, so Astrolab has plenty of time to perfect their design. The big dream for Flex is for the rover to be used in multiple applications, not just SpaceX missions. The company has plans to enter their design into NASA's Lunar Terrain Vehicle competition, so they could very well be selected to accompany NASA-led missions as well. And who knows? Since the Flex can be remotely operated, it's possible that fleets of these rovers could be sent ahead of colonists to move cargo around and begin the construction process before an astronaut even sets foot on the moon or Mars. NASA has a problem. The Deep Space Network just can't keep up with the new space race. The DSN is an array of gigantic antennas placed in key areas around the globe. Currently, there are 3 main sites in California, Australia, and Spain, and they are responsible for all communications further than our immediate orbit. Moon missions, asteroid interception, outer solar array system exploration, and of course, far-ranging probes like Voyager and New Horizons all rely on this network to pass information back and forth as well as receive orders. And for many years, the DSN had enough power to handle everything NASA was using it for. But then Artemis 1 launched, and the weaknesses in the system finally showed up. The DSN just isn't powerful enough to keep up with all this traffic. Truthfully, the problem started earlier. Given that there are only 3 sites, vehicles and missions using the DSN had to hold to a pretty tight schedule in order to not overwhelm the system. The James Webb Space Telescope's huge data transfers back to Earth are a good example, but luckily the Webb already has to wait for viewing windows where it can be seen by the DSN, so there are natural gaps in the coverage just from Earth's rotation. But Artemis 1 was a real wake-up call for NASA. The DSN used 1,774 hours of communication time during the mission, keeping near constant communication with the Orion capsule and all the CubeSats that were providing support, and it was near constant because the network had to split its focus between the supporting satellites and the pod for the entire mission. Definitely not an ideal situation. But this also means that other missions like the James Webb and the Perseverance Mars rover had to give up that time. Imaging time was lost for the Webb, and if an emergency had struck for Perseverance, there wouldn't have been anything NASA could do. Most of this issue is because NASA simply didn't have the budget to expand the network, even though Artemis has been on the books for over a decade now. Running a communications network is expensive, and the sort of planning it takes to prepare for a mission more than a decade away isn't often in the focus for a House committee. And NASA is paying the price for it now. There are a couple of expansion plans for the cislunar communications network on the go right now, not least of which is the construction of 6 18-meter antennas on the moon's surface to help the DSN handle all the new communications traffic, but that's not until 2027. So if there isn't some extra funding released for DSN upgrades soon, the next couple of Artemis missions are going to be dealing with some dangerous communications blackouts. Planet. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.